In this problem, we have petroleum being loaded from truck tanks into an underground storage tank. And I think the key concept here is that truck tanks are small. I mean, they look kind of big to us, but they're small compared to the size of this very, very big underground storage tank. Okay, both of these tanks, the truck and the underground storage, are in the shape of right cylinders, so that's important. But here's where it really gets useful. The underground storage has 3 times the circumference and 6 times the length of the truck tanks. So we're going to use that to figure out how many truck tanks it would require to fill the large underground storage tank. And you can draw a little picture of a cylinder if that helps. Here's what we're dealing with here. This is a cylinder. Okay, this is not great artwork, but that's roughly what we're dealing with. And the volume of a cylinder is equal to the area times the height. Okay, or the area times the length, however you like to call it. Well, if that's height and this is area, and the area is related to a circle, right? The ends of a cylinder are circles. What I can say is this is pi r squared times h. Okay, that's the formula for the volume of a cylinder. We're going to need that. Now, let's call, I've got 2 cylinders here, and one is a truck and one is a storage. So I'm going to say let's see, what do I know? Okay, I know the underground storage here. Circumference underground compared to the circumference of the truck is a factor of 3, right? We know that it's given to us. We're told that the circumference of the underground storage is 3 times the circumference of the truck. Now let's talk about what circumference is. That's 2 pi times r. So 2 pi times the radius of the underground storage divided by 2 pi times the radius of the truck storage. That's what equals 3. And if you look at this, those 2 pi's are going to cancel each other out. So by telling me the ratio of the circumferences, it has also told me the ratio of the radii of these tanks. And that's useful because we want to figure out the volume ratio. So let's set up another equation right here. The volume of the underground storage compared to the volume of the truck tank is going to be equal to pi times the radius of the underground storage squared times the height of the underground storage divided by, and now we're going to do it for trucks, r squared for the truck and h for the truck. Okay, well, the pi's cancel out again. That's nice. And this ru divided by rt, okay, I can rearrange this equation as follows. I can say ru divided by rt, and that thing is squared. And then I can multiply that by hu divided by ht. Well, we've already shown that ru divided by rt is 3. Okay, so that's going to be 3 squared. And earlier in the problem, it told me that it had 6 times the length. See this right here? 6 times the length. So that is a ratio of 6 when it comes to the heights. So what is 3 squared times 6? Well, that's 9 times 6, so that's 54. In other words, the underground storage has a volume that is 54 times greater than the truck storage. That's how many trucks it would take to fill the underground storage.